So yes, we're recording now, and it looks like the equation for that is the um, y is equal to the y-intercept plus the slope times x, or what is that? The response variable is equal to the y-intercept plus the slope times the explanatory variable.
Okay, that doesn't make sense. Dumb it down. What numbers are going where? Because I'm looking down in the summary, and it says y equals b to the 0 plus b1 x, where
Okay.
b0 is the y-intercept and the line, and b1 is the slope of the line. So given the numbers that we have, 2.0 plus 1.5x,
Yeah, so just follow that equation, and then where y is equal to b0, or the y-intercept plus b1 times x, or the slope times x.
girls, is this making sense to you, or am I the only one in left field?
I'm not getting it either. Why?
Okay, I put it into my screen share. I tried to make it easier to understand.
Okay, so you have y equals bo plus b1 x, y-intercept plus slope x. So our y-intercept is 2.0.
Yeah. I guess it's kind of confusing because when you see y-intercept, you might think it's the y. Um,
Well, I was trying to calculate something, the 2.0 plus 1.5x, like, okay, get rid of the x, or, trying to.
right. So all that the y-intercept is it's where, like, it's a point on the graph that the slope goes through. And so it really doesn't have anything to do with what x or y is or like the equation itself. It's just like a starting point for the slope. So in like algebra, the equation that you would have normally seen would be y equals mx plus b. That's the one we're used to seeing.
Mm-hmm.
And b would be the y-intercept. Um, in this case, the reason why it got switched is just in case there were different variables, like that they would do b plus mx1 plus mx2 plus mx3. That's why they switched around the concept, and then the m is going to be b1 instead of m. And so for these equations, the y-intercept, or that point on the graph where, like I was saying, if the slope was 1.5, it would have whatever. But the point is that the y-intercept would be 2. So we would start at y2, like here, and then the slope would look like this. That's what the y-intercept is. It's just a point on the graph that the line goes through. That was kind of a lot of useless information, but hopefully kind of helps you understand what the y-intercept is. And
So for number 4, the slope would just be 1.5.
Mm-hmm.
Okay, 5. Given the linear regression equation, negative 3.0 plus 0.25x, what is the predicted value of x, or a value of y when x is 16? So we're just going to plug that in like we normally would. So we have negative 3.0 plus 0.25 times 16. Which is 4. So we have negative 3 plus 4, so 1. Did you guys get 1?
Yep.
How did you get 1?
What's 16 divided by 4?
3 or 4.
Yeah, and then you have negative 3 plus 4 equals.
Oh.
For the next 7 questions, use the math self-efficiency. Be sure to use the confidence data for the explanatory variable. Confidence data. Okay, so let's get okay, so we're going to use one of the quantitative ones. Make a scatter plot for the math self-efficiency data.
Is number 5 1?
Yes.
Because okay.
This is annoying. I still have information in there from last time. So now we gotta go back and delete all of the information we didn't use. Let's see how many are in the new one. $140. All right, this is what mine looks like. That. Does your guys' look like that?
Yeah.
Mm-hmm.
So hot dog shape, hamburger, banana.
I put hot dog.
Just because it has a slight increase, it's not a banana. Based on the shape of the scatter plot you produced in last question, what could you say about the appropriateness of using simple linear regression to model these data? Simple linear appropriate if simple are we safe to say that it's appropriate?
That's what I put.
Because it seems pretty like the other ones. Uh-oh, I didn't save number 5. Okay, 8. How many observations are in this data? How many observations? So we're counting these? 138.
Does it give us under?
Okay, so I'm not sure about 8, if it's like 138, but the y-intercept, that one, 1.296. Is that what you guys got on number 9?
Yeah.
I mean, it's the number there, the y-intercept. What is the slope? .042.
And that's what I have too.
What is the predicted value of y when x is 4?
What did you guys get for 9?
1.296.
Okay.
What are we putting on number 8? How many observations are in the data?
Hold on. I think this is why I don't like this class. Okay. So
This is the exact reason why you don't like this class.
we need to switch the variables. What you have in column Y
No.
needs to go into
Oh
X.
shoot.
Why?
I knew it was gonna be something stupid.
Because the predicted variable is the score of the test and not what the confidence value that it's putting down, that the students are putting down.
So then, did you get different answers for 9 and 10?
Well, I actually got the same answers, but then when I submitted my group quiz, I got them wrong. So I believe it's right now.
Okay. So I just switched mine. Let's see what answers we were on. Oh, the observations in the data. Did you put, let's see that, 142 minus 4. Or is there a different number somewhere that I'm missing? Is it 138 on number 8?
8 should be 139.
139. How did you get 139? Did I calculate wrong?
Well, the way that I did it was I just went to the math efficiency Excel sheet, looked how many there was, and then I minused one because it starts on cell 2 or on row 2.
Okay, but that is all it is just how many.
Yes.
Okay.
Okay, 'cause mine is
Or you could also do the whole count equation and do the column, which I did after. That works too.
a 140 take away 1. Okay, I see that.
Mm-mm.
So 9, the y-intercept.
Do you have
my
18
number changed.
points? Do you have
18.69.
18.6? Yeah. Okay.
Yes.
I thought maybe I did something wrong.
Answers make so much more
18.69,
sense.
and the slope would change to 12.695. 12.695. 11, what is the predicted value of y when x is 4?
Okay, I'm pretty confident that the answers are going to be right now.
Well, because we can turn it in first too and see what we get.
So for question 9, you got 18.69.
Yes.
Yes.
And then for 10, you got 12.695.
Yes.
Yes.
Okay. So then 11, you just put in 4 into the cell marked X, or the cell below the cell marked X.
Oh, where it
So
says 6.
Yeah.
what are you talking about?
Oh.
On the Excel sheet,
Yeah.
there is a cell marked X. That just
Yes.
is all that is. It's the X variable for or what the Y variable will be if you plug in that value of X.
Okay, so when I put that in, then the predicted was 69.469.
Yeah. And based on the Excel sheet that we're doing on, which is the confidence level of the students compared to the score that they get on their quiz, all that's saying is that on average, when a person would mark with a confidence level of 4 out of 6, they would get basically a 69.4 on the quiz or whatever exam.
Okay.
All right, 12. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is maximum?
Would that be the 91 for number 12?
Where did you get 91? The 91.842?
Yeah, because it says the maximum. So is that like the confidence where you have upper and lower?
That makes sense to me.
What it's asking for, let's see. It's asking for what the maximum Y is for a value of x. So you put in the largest value of x to get the largest value for y. So on a scale from 1 to 6, the largest x value would be 6. So if you plug in 6 into the x cell.
Oh,
117? Or are you going back to the 94.859?
Yes.
okay.
90, what was that?
94.
94.8.
94.49.
Hold on.
I got 94.859.
I'm wrong. Yeah, 859. Just kidding.
How many explanatory independent variables are present in similar linear regression? I'm guessing saying more than 2, but what is... Josh, on number 13, where I was originally thinking more than 2, but what numbers, when I'm looking at the quantitative linear regression thing, where am I looking to see those numbers?
I don't know if it's in our lesson.
Of course, it's not in our lesson.
I think it would be 2.
But this is the way that I figured it out, right? We determined that what we've been doing on the Excel was a simple linear regression, right? Because of question 7 on the group quiz. It says simple linear regression is appropriate for this data. And so looking at the data that we have there that we put in, how many x values are there? Because x value is the explanatory variable. So how many x values are there? And then the response variable is y values. So how many y values do we have? And so in the case of the data that we've been, or the Excel sheet data we've been using, there's only one x value and one y value. And so I just put 1 and 1. I think that's what makes it simple, is that there is a direct correlation between the x value to the y value. Let's see if it says anything about multiples. Sometimes it is necessary to use more than one variable. So in that case, it would be a multiple regression if there's multiple independent variables. And it doesn't say anything about if there's multiple y variables. I don't think there is, because y is what is being predicted. There can only really be one prediction. think it was just one of those things that was implied throughout the lesson was that there would just be the one. But yeah, it's just gonna be the answer's gonna be 1 for both 13 and 14.
Okay.
Yeah, that makes sense.
For 13 and 14, what did you say again?
1.
They'll both be 1. Because independent is X and dependent is Y.
You think we'll make it through this entire semester without the TA joining our group?
I'm going to say yes. It doesn't help that we meet at random times
That's true.
I know.
for every week. If it was the same time every week, then that might be easier. Okay, we have one more, and I'm seeing a little. I don't know.
Yeah, I'd have to say I don't know. I don't know it.
What 15 is asking?
Yeah.
Well, I was thinking the circumference. I was thinking D, just because circumference, because it is being used to predict the size of the hat. But is that correct?
It sounds good.
Because that very one, it says, meaning the company wants to predict size of the hat given the circumference. Josh, is that right?
It's
Didn't he already say it's not right?
no.
Why?
Okay. I guess the best way to put it is that would you agree if I said that the response variable is the variable that is being or that they want to predict?
I'd
Like,
probably agree with anything you said just because you understand stuff more than I do.
okay, so the way that it works is based on our lesson, right? You have an independent variable, which is the explanatory or the x variable, which is not affected by what happens to the other variables. The dependent or the response variable or the y variable is the variable which is affected by what happens to the other variables. So, with that information, the question is asking what is the response variable. So, what's they're asking if x is this, then what is the y variable? And so, in the statement prior to the question, it says the company wants to predict size of hat given a circumference. So based on that sentence, the the company wants to predict the size of the hat. So the size of the hat, we can already tell from right there that that's going to be the response variable, the y variable, and that given the circumference, that the circumference is going to be the explanatory variable or the x variable. That they want to use the circumference of the hat to predict the size based on that sentence. So,
Okay.
so the response variable or the y variable or the variable that is going to be predicted is going to be the size of the hats.
So it would be C.
Close.
What? No, I just submitted it. What do you mean no? Dang it.
Would it be A?
It's A.
Oh,
Because
boo.
circumference is
Waited
not
for
being
Amber to say
predicted.
something.
Right as I submit it, you're like,
Is it the only
no,
one
no,
left?
that's not
Could it be
it.
that one?
So if you look at C, it says the size of the hat because it is used to predict circumference. And the companies are actually wanting to do it the other way, where circumference is predicting the size of the hat. And so the only other option we have is A. It's wordplay. It took me a little bit to
Yeah,
get that one
see,
too.
that's what was confusing me.
All right, so now let's redo all
Did you just miss
this.
that one? Was that the only one that was missed?
Yes.
Okay.
So number five was 1. Number 6, hot dog shape. Number 7, A, simple linear. How many observations were in the data? I don't remember. 9. Started on 2. So 139. 9. What is the y-intercept? Is that 18.69?
Mm-hmm.
69. What is the slope?
Yes. 12.
12.65.
Yeah.
11. What is the predicted value of x or of y when x is 4?
It was 69.469.
What was it? 69?
Yeah, 6 for 11, 69.469.
The confidence data resulted. What is the maximum predicted of x?
Then 12 was 94.859.
4.859. I wanted to choose on that one. If you look at the spreadsheet, all the way over on the right, 117.445.
Wait, what? I got 3 wrong. What did you guys get for 3?
2.
Let's see. Oh, yeah.
It's 2.0, right?
Mm-hmm.
Mm-hmm. Did you
All
put
right,
2
Josh.
comma 0?
Number 15.
A.
I chose. I originally chose D, and you said no, that's wrong, and so then I chose D, and then I submitted it, and I got it wrong. So the size of hat because of the variable being predicted.
Mm-hmm.
That's hilarious. Yay.
This lesson wasn't too bad either, considering some of the other past lessons we've had.
Yeah.
Mm-hmm.
I think I started at like 8. and was able to do both lessons and quizzes. So that's nice. I don't understand this. Okay. Have you guys done the homework?
Are we still
We did
recording?